Okay, use the potential zeros above to list the potential binomial factors of p of x in the form ax minus b, where a is an element of the natural numbers and b is an element of the integers. Got all that? The point of this theorem is, if you're looking for zeros of a polynomial, they are the factors of the last number in the polynomial over the factors of the first number. And so for this one, that means the factors of 9, all of them, over the factors of 5. 9, sadly, has, well, let's see, 3 factors, 1, 3, and 9. But it's worse than that, actually. It's plus or minus 1, and plus or minus 3, and plus or minus 9. Those are all the numbers that can divide into 9. And the factors of 5 are plus or minus 1, and plus or minus 5. So we get to do every single possible combination of those numbers. We have to do 1 over 1 and the positive version. We have to do 1 over 5, which would be x minus 1/5, and x plus 1/5. Now, that's how I would normally write them if I were trying to go fast, but unfortunately, they want b to be an integer, and 1/5 isn't. The way you have to fix this is multiply both of these by the common denominator, 5, and turn them into 5x minus 1 and 5x plus 1. I don't like writing factors like this, but that's what they want, so fine, we'll deliver. So that takes care of that factor. Then we have 3 over 1, which is just plain old 3. So we get x plus 3 and x minus 3. And then we get 3 over 5, which I want to write as x minus 3/5 and x plus 3/5. But they don't want that. They want them both multiplied by 5. So we get 5x minus 3 and 5x plus 3. Some people are really fast at writing these out in integer form. I never have been. I always have to write them in this form first and then do the correction afterwards. Okay, so what have I done? 1 over 1, check. 1 over 5, check. 3 over 1, check. 3 over 5, check. Now 9 over 1 is going to be x plus 9 and x minus 9. And finally, 9 over 5. So we're going to get x minus 9/5 or x plus 9/5. Multiply both of those by 5 and we get 5x minus 9 or 5x plus 9. Get rid of these guys now. We don't need them anymore. So those are all the possible factors of that polynomial. They won't all work. This isn't a list of factors that are going to work. They're potential factors. So it's saying try all of these. Some of these should work. And once you find one, you divide it out using synthetic or long division. And now you have a simpler polynomial to work on. As long as you're finding factors that come out, you are gradually winning. So we've got this great big list of factors, and they say, okay, now pretend that you tried 1. Show that that works. So let's say if we think that x equals 1 is 0, some kind of angel shows up and tells us that 1 is one of the zeros, and we have to run with that information. Well, if 1 is a 0, that would mean that x minus 1 is a factor of this polynomial. Now we have two options here. We can divide x minus 1 out using long division, or we can do it by synthetic division. They both work. I think the last example I did was by synthetic division, so I'll do long this time. If we have 5x cubed minus 51x squared plus 55x minus 9. And we're dividing that by x minus 1. Let's see. X goes into 5x cubed, 5x squared times 5x squared times this gives 5x cubed minus 5x squared. Those cancel completely. Minus 51 minus minus 5 is minus 46x squared. And now we start again. X goes into minus 46x squared minus 46x times. Minus 46x times x gives minus 46x to the 2. Minus 46x times minus 1 gives plus 46x. X squareds cancel out like they're supposed to. 55 take away 46 leaves 9x. X goes into 9x 9 times. 9 times x is 9x. 9 times negative 1 is negative 9. Hooray, no remainder. So, taking out x minus 1, that's what we divided out here, has left us with 5x squared minus 46x plus 9. That's a quadratic. And if it's a quadratic, then the factoring by decomposition should work. 5 times 9 is 45. I'm doing this kind of fast because I'm hurting for space and because I trust you're up on your factoring techniques. And also because this isn't the only factoring technique you could use, so I don't want to harp too much on a technique you may not even like. But if I were factoring this, I would split it up this way. And then from the first two terms, you take out 5x. And from the second two terms, you take out negative 1. And now we have x minus 1, x minus 9, 5x minus 1. So there it is factored. And from each of these factors, we get one of our zeros. X minus 1 is a factor. That means x equals 1 is a 0. X minus 9 is a factor. That means x equals 9 is a 0. And if 5x minus 1 is a factor, that means if you can't eyeball this one, you just write equals 0 and then solve it. You get 5x equals 1. So x equals positive 1/5 is our last 0. And now the last part's kind of an anticlimax. We just did it. Solve the equation, blah, 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 equals 0. The solutions are 1, 9, and 1/5.